In today's tutorial, we're going to use Blender's geometry nodes to create this particular simple abstract sci-fi loop. We're going to try to keep it step by step, and we're going to explain exactly why we're doing what we're doing so that even beginners can get an intuition of exactly how they can go about creating their own animations like this and create their own unique animations real soon. So with that, let's go ahead and actually begin today's tutorial. We're going to go in a slightly different route than usual by creating the animation first and then going into geometry nodes. So let's go ahead and select our camera, press Alt-G to clear its location, Alt-R to clear its rotation, and then press RX90 to rotate it on the x-axis by 90 degrees so that it's looking forward. Now, why we're doing this is because essentially we want to take a look at everything, and explaining why we're doing the math makes so much more sense from within the camera's view as it's actually animating. So let's go ahead and bring our cursor to the junction of these two windows, pull it just to create a little bit more space, press the back arrow to go to frame 0, and then tap I to create a keyframe for the location, rotation, and scale for the camera. Now we want the last frame to be frame 600 so that we get a 10-second long animation at 60 frames per second. So let's go to frame 600 and then just press GY followed by any distance that you want the camera to move. So I want to move it by, let's say, 32 meters. So I'll just press 32 and then tap enter and then tap I to add in a keyframe over there. Now we're going to change this end frame to 600 so that it actually loops after 600 frames. And then if we were to play the animation right now, it'll start off slow, it'll speed up towards the center and slow down at the end again. So to change that, we'll tap A to select both the keyframes, and then we'll tap T and then change the interpolation mode to linear. And that way we'll get a smooth motion all the way from the beginning to the end. Now that we have this motion created, we can actually go into the camera view by pressing this icon over here or pressing numpad 0 on your numpad. So right now we won't be able to see anything because we don't really have anything created. So let's go ahead and start the actual creation. Let's select the default cube. Let's just bring this junction down a bit. Bring our cursor to this particular corner of the junction of these two windows, click and drag to create a new window and change this from the 3D viewport to the geometry node editor. Now we can tap N to remove the side panel and press this plus button to create a new geometry node tree. We don't need the default cube, so let's select the group input and tap delete to remove it. Now let's press Shift A and search for a mesh line and plug that into the group output. So the actual method in which we're planning on using this or creating this animation is we want a line on the y-axis which will give us different points. On those points, we'll be adding in pentagons, and those pentagons will undergo two types of rotations, and they will slowly appear based on the location of the camera. So why they are going to have two types of rotations, we'll explain once we actually create the pentagons. So the first thing that we see is that this mesh line is actually going up on the z-axis. We don't want that. We want it on the y-axis. Let's change the offset to a value of 1 on not the x-axis or the z-axis, but a value of 1 on the y-axis. Now, apart from that, we want there to be, let's say, at least 32 pentagons. So let's change this count to 32. Apart from that, there's two things that I want to do. The first thing is I actually want each alternate pentagon to be moving in opposite directions. So in order to attain that opposite rotation, instead of making that in one single tree, we'll create one tree with one rotation and we'll reverse the rotation for a separate geometry node tree. So what we'll do is we'll just increase this to a value of 2 meters so that there's going to be a gap of 1 meter between each of these, and we can use the second one to fill in those gaps. Apart from that, right now, since we have 32 and 2 meters, this actually goes on till 64 meters, but our camera moves only up to 32 meters. Now, I think that's actually a good thing because we want this to be perfectly looping. So when we actually go all the way to the end, there will still be a few pentagons that are present so that it becomes a perfectly seamless loop and you don't get an abrupt change from when the camera goes here and resets back to the original position. So that seems perfectly all right. And now with this line created, we want to instance these pentagons on each point on this line. So to do that, we'll press Shift A, search for an instance on points node and plug that in right over here. Now for the instance, we're going to use a pentagon, which is actually a curved circle. So let's press Shift A, search for a curved circle and plug that into the instance. Now remember, the curved circle is going to be a circle. To change it to a pentagon, we change the resolution down to a value of 5. So that way we get a circle with only 5 points, which is nothing but a pentagon. Now it's obviously rotated on the wrong axis, so we need to just rotate it on the x-axis by 90 degrees, and that should give us exactly what we want. Now that we have these pentagons, we need to start creating the rotations so that it's rotating over time. The actual thing that I want is I want these pentagons to rotate throughout the animation. So let's press Shift A, search for a rotate instances node and plug that in just before the group output. Now, if we were to rotate it about the y-axis, you'll see that we get a different rotation, and that's because we're using the local space. So locally, because we rotated this about the x-axis, it's the actual z rotation that we want. So if we rotate about the z, we get the rotation that we want. However, instead of doing this, you can always uncheck the local space and then change this back to 0 and rotate it about the global y-axis. So now that we have this rotating about the global y-axis, how much do we want to rotate this by? We want it such that it rotates over time, and we can either do that by just adding a value node and keyframing the values, or we can add a scene time node. So if we use a scene time node, we can use this seconds value to rotate just the y-axis. But if we plug this in right like this, you see we don't have control over just the y. It does it for all of the axes. That's not what we want. So to get control over just one axis, we're going to press Shift A and search for a combine XYZ node. And now we can plug the seconds into just the Y, and it'll rotate over time about just the Y axis. However, this does not give me too much control. So I'm actually going to not use this, and I'm going to keyframe a value over here itself. So what I'm going to do is I'm going to press Shift A, search for a combine XYZ, take this value node, plug it into the Y, and plug this into the rotation of this rotate instances node. Next, I want to rotate this by, let's say, an arbitrary amount, let's say 1/4 of a full circle. So the way I'm going to do that is I'm actually going to add in keyframes for one full circle and then just add in another math node to divide that by 4. So let's go ahead and just go to frame 0 and tap I to add in a keyframe for frame 0, and then go to frame 600 and then make this one full circle. Remember, one full circle is 2 star pi radians. So we type 2 star pi and tap enter, and then hover over it and tap I. So now that we have these two keyframes, it's going to be the same thing where it starts off slow, speeds up in the middle. We don't want that. So we're going to press A, T, and then linear so that we get a smooth rotation throughout the entire duration of the animation. Now this rotates by one full rotation. We don't necessarily need it to rotate that fast. So in order to slow down the rotation, what I'm going to do is press Shift A, search for a math node, and I'm going to change this from add to divide, and I'm going to divide it by a value of 4. So now that we have this divided by 4, we can just arrange this a little better and then simply take this and see what the animation looks like. Now what we're going to be doing is we're going to actually use a trim curve node to have these pentagons slowly appear over time. For that, we're going to press Shift A and search for a trim curve node and plug that in right over here. Now, of course, this actually comes in a lot later, and we will be changing this trim based on the position of the camera and all of that. However, just to understand why we're adding in the second set of rotation, I think it's easier to see it if we add in a little bit of trim right here. So the way we're going to be trimming this is by using this start value so that it slowly goes from 1 to a value of 0 and it appears in over time. However, if you see, all of these are going to be rotating or appearing from this particular point. But since the entire thing is rotating over time, as you see, the point from which it's going to start appearing slowly moves. Originally at frame 0, it was all the way to our right, but as we move forward and forward, it comes all the way down here. We don't want that. We want it such that at any point of time, the point from which this starts emerging should remain at the same position. So how do we do that? The way we do that is, since we're slowly moving front, the ones that are present in front should be rotated to exactly counteract the overall rotation of this particular object. So for that, we're going to have to rotate each instance by a little bit, and depending on how far it is, it has to be rotated by that amount. So we can do that by either rotating it based on the position, or since these are instances, we can rotate it based on the index value. So let's go ahead and do that. Let's duplicate this rotate instance node, plug that in right over here. Now, what we want to do is we want to rotate each of these based off of its index value. We can press Shift A, search for an index node, and now you see this index gives it a value of 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So we can press Shift A, search for another combine XYZ, and plug this index into the Y and plug this into the rotation. So now if we do this, you can see how we are getting some sort of a rotation happening based off of the indices. You can control that using a math node. So let's press Shift A, search for a math node, and plug that in right over here. If we change this from add to multiply, you can see that just by changing this multiplication value, how we're able to get like the amount of twists that we add in. So now we could just manually use trial and error to see exactly how much we need to multiply it by to, counteract that particular twist, right now you can see it is clearly way too much. The points are over there, there, and so on and so forth. If we reduce this by a very tiny amount, let's go like that, maybe it'll start counteracting the rotation. So you can see as this comes in, it's actually starting to move away, I feel. So we'd have to actually play around with this so that we get it such that it just perfectly counterbalances and it's always acting in that exact position. So let's say it starts here. As it rotates, we'd want it to be such that it actually remains right there. Now, doing trial and error is possible, but that's too much of work. Since we know math, we can use it to actually calculate how much this should rotate. So remember, we want all of these to rotate by essentially 1/4 of a circle once this reaches the 16th index. So to do that, what we can do is, remember, one full rotation is 360 degrees. So let's press Shift A, search for a math node, and essentially we want to take this index. Let's just mute this math node for now, and we want this index to be multiplied by 360 divided by 16 because we want it to rotate by, essentially, let's say one full circle by the time this reaches the 16th index. So let's go ahead and change this to 360 divided by 16. Now, remember that we weren't doing one full rotation because we divided it by 4 over here. So because we divided it by 4 over here, we're going to have to go ahead and divide this by 4 as well. So let's change this from multiply to divide and divide it by a value of 4. And let's unmute this node by tapping M. So now hopefully we get an idea of the math that we just did. Let's go back into our camera view. And when we actually see this, it's clearly not working. It's moving away. And the reason that's moving away is because when we divided this as 360 divided by 16 and all of that, we chose 360 degrees. But when we plug it into a combined XYZ node, this is going to be taking in radians as an input. So to change this from degrees to radians, we have to add in another math node. Let's press Shift A, search for a math node, and we have to change it to go from conversions to radians. So now this is going to take it from degrees to radians, and we should see that this particular point becomes invariant to where it moves. However, we see that this is still slowly moving away, and that's solely because currently it's moving in the opposite direction. We actually need it to rotate in the other direction. So instead of multiplying this by a positive 22.5, let's go ahead and just change this to a negative 22.5. So as soon as we do that, it should perfectly land up at the exact same position at every single time instance. So you see through the entire loop, we get it to be perfectly looping, and it's always going to be at this exact point, or it's going to be starting at exactly this point every single time, which is exactly what we want. However, I don't actually want it to be starting over here. I want it to be starting down here. So we can just take the entire thing and just rotate it by pressing Shift A, search for a transform geometry, and giving the entire thing a little bit of a rotation about the Y, just so that it starts off at the bottom somewhere. Let's say somewhere around that should be good enough. There shouldn't be any other issues to it. So now we have that working out perfectly. The next thing that we need to do is actually make sure that this entire thing starts trimming into existence based off of the distance from the camera. Now, remember, if this is starting to get too much, we should always be labeling all of these and arranging them so that it becomes a lot easier to use and understand why we're doing what we're doing. To do that, you can always just select these, press Ctrl J to add in a frame, and you can tap F2 to actually label them. So let's say this is creating pentagons, and so on and so forth. So this is for the rotation. So let's take this, Ctrl J, Ctrl F2, or just F2, and then press rotations, so on and so forth. If you want to just get the downloaded file or the created file that is already arranged, you can do that from my Patreon, and it will be linked down below. You can either join the monthly subscription where you'll be getting all of the files that I create throughout the month, or if you want just this individual file, you can go ahead and download just this one, which will give you the file along with the 4K 60 FPS animations and some wallpapers. If not, you can always like the video, share it, and just watch it fully to help support me as well. Now, we will be having the completed arranged version on Patreon, but for now, let's go ahead and see what else we can do to start trimming this based off of the distance from the camera. To get the distance from the camera, we can press Shift A and search for an object info node and take in the actual location data of the camera. For the object, we're going to choose the camera, and remember, because the camera is moving, we have to use the relative distance. Now we want just the Y location of the camera, so let's press Shift A, search for a separate XYZ node and then plug this location into the vector and use this Y location to actually find the Y position of the camera. Apart from that, we're gonna press Shift A and search for a position node, which will give us the position of each of these splines. And we want the Y position of these. So let's just duplicate this separate XYZ node and plug this in right over there. So now we can actually take the difference of these two to give us the distance from the camera to each of these particular points. So in order to find the distance, we press Shift A, search for a math node, and then we simply change this from add to subtract, and we subtract the Y values here and here. Now we want to plug this into the start, but there's a few problems. The first thing is, remember, these are still instances. So we don't actually have control over each one independently. So to get control over each one individually, we have to realize the instances. So let's press Shift A, search for a realize instances node and plug that in right over here. Now you can see everything that's present behind the camera is going to slowly appear, but that's not what we want. We want at least a few of them that are present ahead of the camera to be visible. So to do that, let's just take another subtract node, plug that in right over here. And as we increase this value, you can see we get a number that's going to be appearing in front. And now this is going to make each one appear independently. We don't want that. We want like a range so that a few of them start appearing over time. So to do that, we can go ahead and use another math node. Let's press Shift D, change this from subtract to, let's say, divide, and let's just divide it by a large number. Let's say, let's divide by 10. And in this case, we don't have to subtract by a large number anymore. So let's just subtract by maybe a value of 2. So now that we do this, when we actually play the animation, you can see how they slowly start appearing. Let's go into our camera view, and this is what it looks like. The next thing is, okay, I feel like these pentagons are fairly small. So let's increase the size of the pentagon by changing this radius over here from 1 to maybe 3. But now we don't really get to see the pentagons. So in order to be able to see more of the pentagons, let's select the camera, go down to the camera properties and change the focal length down to something like 12. This gives us a nice wide field of view, and I think I like this look a lot better. We always see them appearing from here and slowly going around just as we move forward. So this looks perfectly all right. However, we still don't have any thickness to the pentagons, and we don't have the counterclockwise rotations as well. So let's go ahead and fix those. The first thing, to add in some thickness, let's select this once again. Let's go over to the side, and then let's go ahead and just move this group output and press Shift A and search for a fillet curve node. So what this is going to do is it's going to change these sharp corners into nice rounded corners. So you can change the radius to be whatever you want it to be. I'm just going to give it a very small radius. So let's say something like 0.25. However, I do want it to be a lot more rounded. So in order to do that, I'm going to change it to poly. I'm just going to start increasing this count all the way to 32 so that it becomes nice and smooth. The next thing that I want is for it to have some thickness. So let's press Shift A, search for a curve to mesh node, and let's plug that in right over here. And for the profile curve, we're going to use another curve circle. Now this curve circle does not have to be this high poly. So let's reduce the resolution down to something like 6. And let's plug that into the profile curve. It's going to be way too fat, so let's reduce this radius down to something like 0.1. And apart from that, I want it to be such that as it goes towards the end, it becomes even thinner. So in order to do that, we're going to have to use something called a set curve radius. So let's press Shift A, search for a set curve radius, plug that in right over here. So for the actual radius, we're going to use the spline parameter or the factor of the spline parameter. So let's press Shift A, search for a spline parameter. Now this factor is going to go from 0 to 1, essentially from the start to the end. So let's plug this into the radius and see what we get. And that is exactly what we want. However, I don't actually want this to be this fat either. So I'm going to change this radius down even more. Let's make it 0.01. And maybe that's too thin, so let's go with 0.025. Of course, this is your personal preference and a little bit of trial and error, but now we have something that's looking fairly nice. The next thing that we need to do is create a second version of this that rotates in the opposite direction. So we're going to go ahead and just duplicate this that we already have and move it by, let's say, 1 unit. So let's just select this, press Shift D to duplicate it, and then press GY followed by 1. And that just moves it by exactly 1 unit. So now we have 2 of these that should be doing the exact same thing right now. However, obviously we don't want them to do the exact same thing. We need this to be in the opposite direction. So the way we do that is we play around with the geometry node tree over here. But if we make changes to this right now, it'll change it for both of them. We don't want that. We want it to be its own independent one. So we just press this little 2 button and now it becomes its own geometry node tree. As you can see, it's labeled as 0.001. And now if we make changes to this, it's not going to affect the other thing. So the first thing that we can do is we can change the direction of this rotation. So let's change this from -22 to +22.5. And then apart from that, this rotation that's happening should also be in the opposite direction. So let's go ahead and multiply this by a value of -4. And that should take care of most of it. However, it still is not starting off from the bottom. So to make it start from the bottom, let's just go ahead and play around with this to rotate it to be appropriate. And the end is what we have to play around with instead of the start. So for this trim curve node, we can just shift this from start to end, but instead of doing just the end, we're gonna have to do 1 minus the end. So let's search for a math node and change this to subtract and then make this 1 minus this value. So the reason why we're doing this is because previously we got these to appear by just changing the start value from a value of 1 to 0. However, now we want it to go from the opposite direction. So we want the start to always be at 0 and we want the end to go slowly from 1 all the way to 0. However, remember this output literally goes from 1 to 0, but we need this to now go from 0 to 1. So that's why we just do 1 minus this output, plug that into the end, and now it should be going in the opposite direction. So that looks pretty good. We have both of them going in opposite directions and we have some motion over time. However, this curve is really fat over here and thin at the end. We don't want that. We want it to be the exact opposite. So we're gonna have to do the same thing over here. We're gonna have to press Shift A, search for a math node, and we're gonna have to change this to subtract, and we have to do 1 minus whatever answer we get from this. So let's plug this in right there. And now take this output and plug this into the set curve radius. So now we should have them going in opposite directions, working exactly as is. Now I don't actually want to see this bottom as it slowly appears. So in order to fix that, we're just gonna add in a plane. We're gonna do that later on. First, let's go ahead and just set material for these. So let's press Shift A, search for a set material node, plug that in right over here, and we can choose the default material. Now, for the other geometry node, let's just go ahead and select the other one. So if you see this one is present over here, we made changes to only this geometry node by adding in the material. Let's select this and press Shift A and search for another material node and plug that set material right there. We need to create a new material because this has only one material. Let's press this plus button to create a new slot and this new to create a new material. And let's select that from down here. Now we have two different materials and we can go ahead and play around with them later on. So to mess around with the materials, let's go ahead and change this from the geometry node editor to the shader editor. So now for material 001, all I want it to be is a simple emission material. So let's delete the principal BSDF, press Shift A, search for an emission node and simply plug that into the surface. Now to see the actual changes that you make, let's change this from a viewport shading of solid to a viewport shading of rendered. So now you can actually switch off overlays and see that we have some sort of emission, but we want some different colors. So maybe we'll go ahead with a red and blue shading scheme. So let's change this to red and just increase the brightness to something really bright. Let's go with the brightness of maybe 25. So now that looks good, but we would also want this to have some sort of a bloom effect to make this look really nice. So we'll go ahead and add that during the post-processing section. For now, let's select the other object that we had and go ahead and change that material. So let's delete the principal BSDF. Again, remember, if you weren't able to see the material or select it, you could always just play around and just select it over here and then play around with it from here. Let's press Shift A, search for an emission node. Let's plug that into the surface and change this to maybe a bluish color. And let's increase the strength to something like 25. Now we have the two emissive colors. Let's go ahead and change the background all the way to black. And now what we're gonna do is we're gonna just add in a plane to hide the bottom. So let's press Shift A, search for a mesh plane. And now let's just scale it up on the y-axis just like that to be, let's say, 32 units in length. And since we need it not from the center, let's just press GY32 and that should bring it to exactly the start right there and move on all the way to 32. Now, if you actually go into the camera view, we won't be able to see it. So we need to have some sort of lighting to actually reflect onto it. So in order to get that lighting, we already have one default lamp present right here. What we can do is we can just press G and bring it down right about there. And another thing that we'll notice is that we don't see it because it's present perfectly at the level of the camera. Let's actually select it and just press GZ and bring it down somewhere like that and then go back into the camera view and now we see it. Now, this particular light, the default lamp at least, is way too bright. Let's reduce the brightness down to something like 100 and let's just bring it into view. Let's G and bring it down there. Let's say we give this maybe a bluish color. Let's just change this to be bluish and let's Shift D, followed by X to move it over to the side and give this maybe a reddish color. Now that we have a red and a blue light, we can go ahead and create a material for this. But if we were to still play the animation, you see it slowly moves away. In order to ensure that this becomes perfectly seamless, what we're going to do is we're going to select both of those lights that we just created. So this light and this light. We can shift select them from the outliner, shift select the camera, and then press Ctrl P and click set parent to object. So now as the camera moves, the light moves, and you can see that that change does not happen and it remains exactly as it was. The next thing that we need to do is give this some sort of a texture so that it's not this bland. So we press this plus button to create a new texture. Let's increase the metallic all the way to 1, and let's reduce the roughness down to something like 0.3. Now we can see the light, but clearly it's too local and you don't see it all the way over there. What I'm actually going to do is I'm just going to expand the camera, select these two lights, and then press Shift D followed by Y to move them far away as well, so that there's just another set over there. So that looks good enough, but this is still way too regular. We need to create something so that this has some sort of personality. So in order to do that, let's create some sort of a bump texture. So let's press Shift A. Let's search for a noise texture. And now we're going to plug that into the normal, but we need to convert it to normal data. So let's search for a bump node. And now we can take this color, plug that into the height, and plug that into the normal. Now you see it gets twisted, and this is good, but this is not going to help it loop. We need it to be perfectly looping. So in order to make this looping, as you can see clearly, it just changes right at that point. What we can do is we can completely ignore the x-axis and just have this happen only on one axis. So in order to do that, let's just press Ctrl T with the node wrangler enabled to get the texture coordinate or mapping nodes. And you can always add these in manually if node wrangler does not work by pressing Shift A and searching for the texture coordinate and mapping nodes separately and adding them in. Then we'll change this from generated to object, and then we can just simply separate out the XYZ by pressing Shift A, search for a separate XYZ, and using just the x-axis as the vector input. Now the scale is way too large, so let's just reduce this scale down to something that looks nice. Something like that seems good enough, and that should be good. But this still doesn't, give it too much character because it's fairly constant throughout the entire animation. So in order to make this move even more, what we can do is we can go ahead and duplicate this bump node, press Shift D, plug that in right there, so that the normal goes into the normal. And for this height, we're going to use a wave texture. Let's press Shift A, search for a wave texture. And now we can plug this color into the height. But remember, we need this to also be perfectly looping. So what we're going to do is firstly, we're going to change this from X to Y so that the waves occur on the Y axis like that and not longitudinally. Now you can clearly see the position of the waves and there is some sort of character. However, this is not going to be perfectly looping. So in order to get this to perfectly loop, what we're going to do is we're just going to Control Shift click this with the node wrangler enabled so that we just see what the wave texture looks like. And we can take a look at what it looks like at a value of 0. And just for the sake of it, we're going to change this from sine to saw so that it becomes a lot easier for us to see exactly what we're doing. Now we're going to go ahead and just zoom into this edge and play around with this phase offset until we get the start of the edge just over there. So now you see we perfectly get it to match up with the camera. So let's just play around with this. You can hold down Shift to help get much smoother control. And if that is not smooth enough, you can always actually press Shift A, search for a value node, and then search for a math node, and then search for a divide, or just change this to divide and divide by something like 100. And now plug this value in here and this into the phase offset. So now you just get much more control over exactly where you want this to be. Let's go ahead and play around with it until it just perfectly touches the edge. And that looks good. Now let's go ahead, hover over this and tap I. And then on frame 600, we want to ensure that it is at the exact same position. So all we do is just change this till it becomes exactly corresponding to this. So that means right over there, and then tap I. So once you do this, again, remember to go down here, press T and choose linear. You should get a perfect loop for the wave texture as well. So now if we go ahead and see what the principal BSDF looks like by Control Shift clicking it, you'll see you have that texture move over time as well, but it's currently not moving because we have it set to saw. Let's change this to sine. And now you can see how we have the nice little wave-like motions occurring over time as well down, and everything looks good. So once we've changed this to sine, you can see how it moves over time and we have some amount of character added in, and also it perfectly loops over time as well. So now that we have all of that created, we can go ahead and just complete it by doing the post-processing or the compositing. So the first thing that we're going to do is change this from the shader editor to the compositor, and we're going to check use nodes. Now, if you can't see the nodes, you can press period or A and then tilde. You can do a lot of things to bring these in, such as view and then just choose frame all, and that should bring everything into your scene. Then press Shift A and search for a glare node and plug that in just before the composite. We're going to change this from streaks to bloom, and what we're going to do to be able to see this is use this little drop down here and choose compositor always. So now you can actually see the bloom effect occur. Apart from that, I don't want to see anything outside my camera view, so I'm going to select my camera, go down to viewport display and increase pass power 2 all the way to 1. So now we can actually see this happen over time. The next thing that I want is some really nice reflections. So in order to get those, I'm going to go back to my render properties and I'm actually going to switch on ray tracing, and that should add some nice reflections from my emissive objects over here onto this particular plane that I created. And that's actually all there is to creating an animation like this. You can always play around with the different sizes and scales of all of these textures that we have to get different effects, but the overall principle is the exact same. And you can use this or apply it to get various stunning animations. So to actually render it, you have to change this output. We're going to change the frame rate to 60 frames per second. And ideally, I should have done that before I set up the animation so that I get an idea of how fast it actually is moving. However, I'm going to change the output folder to be whichever folder I save the Blender file in. / takes care of that. I'm going to change the file format to FFmpeg video with the encoding changed from Matroska to MPEG-4 and an output quality of perceptually lossless. With all of that, to get a 4K render, I'm going to change this from 100% to 200%, and I'm going to go ahead and press render animation. I hope that actually gave you an intuitive understanding of why we did what we did, and you'll be able to apply that type of thought process while creating your own animations as well. In case you have any doubts, feel free to comment down below, and I will try to respond as much as I can. I'm going to be trying to change formats a bit in the coming few days because I have a few goals that I have to reach by September in order to be able to continue making videos on YouTube like this. So in order to try and reach those goals, I will be trying to post a lot more often, create more products, and see what videos you actually want to see. So do let me know down below, and I will try to create more videos like that and hopefully get more engagement and views on my videos. With that, thank you so much for watching. Feel free to check out other videos on my channel, and until the next video comes out, keep creating and stay creative.